talk about how to solve cube root equations. So cube roots are radicals that have an index of 3. A cube root equation is an equation that includes a cube root. You can solve a cube root equation by raising both sides of the equation to the power of 3 after isolating the radical. So notice here we have a cube root equation, the cube root of x plus 1 equals 4. You can undo that cube root by raising both sides of the equation to the third power. So just some general facts about radical equations now. Now that we've seen square root equations and cube root equations, we can make some general facts about radical equations. And remember, radical equations are equations that include a radical expression. So they can include a square root, they can include a cube root, or even higher roots like fourth roots or fifth roots. So whenever we're solving a radical equation, you always need to first isolate the radical. That's going to make the algebra a whole lot simpler, and it's going to be much easier to solve. Second thing is you want to make sure to look for extraneous solutions when you're working with a radical that has an even index. So square roots will have extraneous solutions, but when we're working for things like cube roots, we're not going to find any extraneous solutions. So here are our problem solving steps. You're going to do opposite operations first to isolate the radical. Then you're going to raise both sides of the equation to the power of 3, and then you're going to use opposite operations to solve for x. Then you're going to plug this value back into the equation and make sure to check your solutions. So now let's go ahead and solve for x. So we have the cube root of x equals 5. So here, since the cube root is already isolated, we're going to go ahead and raise both sides to the third power. So when we do that, we get x equals 5 to the third, which is 125. Remember, we always want to make sure and check our solutions, so we're going to verify that the cube root of 125 is equal to 5. And if you do this on your calculator, you'll find that this does in fact equal 5. So now let's try this equation. We're going to solve for x. So you can see once again we have our cube root isolated. So we're going to undo that cube root by raising both sides to the third power. So we're going to get 2x minus 5 is equal to 3 to the third, which is 27. Now we need to go ahead and solve for x. So to solve for x, the first thing we're going to do is we're going to add 5 to both sides of this equation. When we add 5 to both sides, we're going to get 2x equals 27 plus 5, which is 32. Now we can solve for x by dividing both sides by 2. And when we divide both sides by 2, we get x equals 16. So now we want to make sure that the 16 is the correct answer. So we're going to go back to our original equation, the cube root, and then we're going to do 2, and then instead of x, we're going to substitute 16. So 2 times 16 minus 5, and we're going to verify that that equals 3. So we have the cube root of 2 times 16 is 32, so we have 32 minus 5, and we're making sure that's equal to 3. So this is telling us that the cube root of 32 minus 5, which is 27, and we want to verify that's equal to 3. The cube root of 27 is equal to 3, so this is in fact correct. So now let's go ahead and pause the video and try this example on your own. So you can see here, once again, we have the radical that's isolated, so we can raise both sides to the third power. So what we do is we get 3x minus 1 is equal to 8, and then we're going to solve by adding 1 to both sides and dividing by 3, which gives us x equals 3. When we plug x equals 3 back into the original equation, we get 2 equals 2, which is correct. So now let's try this one. So here, we don't have the cube root already by itself. Okay, so we're going to need to use opposite operations to isolate that cube root. So what I'm going to do here is I'm going to subtract 8 from both sides. And when I subtract 8 from both sides, I get the cube root of 5x plus 1 is equal to 4 minus 8, which is negative 4. Now I can undo that cube root by raising both sides to the third power. When I raise both sides to the third power, I get 5x plus 1 is equal to negative 4 to the third, which is negative 64. Now I'm going to go ahead and solve for x. So in order to solve for x, I'm going to start off by subtracting 1 from both sides. And when I do that, I get 5x equals negative 65. Now I'm going to go ahead and divide both sides by 5. And that gives me x equals negative 13. So now what I need to do is make sure my solutions are correct. So what I'm going to do is I'm going to go ahead and plug this negative 13 back into the original equation. So I have the cube root of 5 times negative 13 plus 1, and then plus 8 on the outside. I want to make sure that's equal to 4. So I have the cube root of negative 65 plus 1 plus 8 is equal to 4. So that's the cube root of negative 64 plus 8, and I'm making sure that's equal to 4. So that's negative 4 plus 8 equals 4, which tells us that 4 equals 4, which is in fact true. Now you can go ahead and pause the video and try doing this example on your own. So here what I'm going to do is, once again, I need to first isolate the cube root, so I'm going to do that by subtracting 4 from both sides. So when I subtract 4 from both sides, I get the cube root of 3x minus 12 equals negative 3, and then I cube both sides. So I have 3x minus 12 equals negative 27, and then I add 12 to both sides. So I have 3x equals negative 15, and then I go ahead and divide both sides by 3, and I have x equals negative 5. When I plug x equals negative 5 back into the original equation, I get 1 equals 1, which is in fact true. So now let's go ahead and try this problem. So we have 2 times the cube root of x minus 1 plus 4 is equal to 6. So we're going to need to do more than one step here to isolate this cube root. First, we're going to start off by subtracting 4, because remember, whenever you're undoing things, you want to do the add or subtract before you do the multiply or divide. So we have 2 times the cube root of x minus 1 is equal to 6 minus 4, which is 2. Now I'm going to go ahead and divide both sides by 2. And so I get the cube root of x minus 1 is equal to 1. Now I'm going to raise both sides of the equation to the third power. And so that's going to give me x minus 1 is equal to 1. Now I can add 1 to both sides. And when I add 1 to both sides, I get x equals 2. So I want to make sure this x equals 2 does work. So I have 2 times the cube root of 2 minus 1 plus 4 is equal to 6. So I have 2 times the cube root of 2 minus 1 is 1, and then I have plus 4, so that's equal to 6. So that means 2 times the cube root of 1 is just 1, so 2 times 1 plus 4 is equal to 6. So 2 plus 4 equals 6 means that 6 equals 6. So that is in fact true. So now you can go ahead and pause the video and try doing this example on your own. So here, once again, I need to do more than one step in order to isolate the cube root. So I start off by subtracting 5. When I subtract 5, I get 4 times the cube root of x minus 2 equals 12. Divide both sides by 4, which gives me the cube root of x minus 2 equals 3. I raise both sides to the third power, so I have x minus 2 equals 27. I add 2 to both sides, so I have x equals 29. When you plug 29 back into the original equation, you get 17 equals 17, which is in fact true. So remember, to solve a cube root equation, you always want to first isolate the cube root using opposite operations. Once you've isolated the cube root, use opposite operations to solve for the variable. Then you always want to remember to plug in and check your solutions.